The centroid is the geometric center of a shape. When coming to a centroid problem, we see an object something like this, a composite object made up of a bunch of simple shapes. We're asked to find the centroid of the area shown. I typically start by looking at the object and trying to break it down into its various parts. As always, you need a sign convention. I've now applied variable labels to all the dimensions I'm going to need. Now when I'm looking at an object like this, I begin by thinking, how would I actually go about making this object? Let's suppose we first started with this rectangular piece. So that's my object number 1. I'm going to start with a great big rectangle. Now the next thing I would do is I would say, okay, let's cut off this top corner up here. That would be a negative object, and I'm going to call that object number 2. Next I would do the same thing. I would cut the bottom corner off this rectangle, and I would call that object number 3. That would be negative. You'll notice I'm taking a complex shape and breaking it up into simple geometry. Next I would cut this circle out of the middle, so that's my object number 4. And last I would take this corner and I would cut that off. So that is what I'll call object number 5. So you can see here the white shape, that's a positive area, and all the red shapes are negative areas. So in the centroid table, the columns are as follows. You have a column for I, you have a column for A sub I, which the area for each shape is going to be in square centimeters. You have a column for the X bar of each shape, which is the horizontal center, and that's going to be in centimeters. You have a column for Y bar for each shape. That's also going to be in centimeters. And the last two columns here are simply multiplications of the area times the X bar and the area times the Y bar. So now there are 5. And a total. So step 3 will be finding areas and centers, and under that we can just begin doing the algebra. So A1, shape 1 is a rectangle, so its area is base times height. Its base is E plus H, and its height is A. Make sure that you include the sign. Each of these areas is going to be positive or negative depending on whether it's a positive or negative area. Now the center of this shape we can see pretty easily. Since the whole thing is 14 centimeters long, its center is a positive 7 centimeters. There's no work necessarily needed for that. And the y is 0. You might wonder why y is 0 and x is positive 7. That's because I've defined my 0, 0 as right here. So the y center is on the x-axis. The x center is 7 centimeters in the positive direction. So now to get these last two columns, we just multiply the numbers together. And I will not require that you show that step in your work. However, you need to make sure that you do it accurately. Now for the second shape is a triangle. And the area of a triangle is 1/2 times base times height. Well, the base is H, this distance, and the height is B. Now shape 2 I told you was cut out of the original shape, so that means that that shape is a negative 10 square centimeters, which we can then put into our chart. Now to figure out where its x and y center are, we got to look at the triangle. If we were to try to balance this triangle, its center would be about right there where I'm going to make this black dot. Now how do we find that? Well, it's 1/3 of the base and 1/3 of the height, but you have to keep in mind it's 1/3 of the base and height away from the side with the right angle. So let's start with my x2, the horizontal center for shape 2. The horizontal center would be h divided by 3, which is going to be 1/3 of the base. However, if we just said h over 3 is going to be 5 divided by 3, and if we just said positive h over 3, that would actually be over here. And that's obviously not where the center of the shape is. So we have to take into account the total length, the total distance from our 0 axis here. So that's going to be E plus H. and then we have to subtract off the h over 3. Now this is a positive distance because our center, our xy plane, originates right here. That's 0, 0. So going over in the positive direction, that's a positive distance. And it's going to be a positive 12.3333. Likewise, for our y center, it's going to be height over 3, which is b over 3. But b over 3 by itself would give us 4 centimeters divided by 3, and that would be about right here. And that's obviously not where the center of that shape is. So we actually have to come up and come back. So there's two ways to say this. You can say b minus b over 3, because here's our center line where the x0 axis is. So b would be up to here, minus b over 3 would be right there. Or the simpler way is to say 2/3 of b. And our y distance is a positive 2.667 centimeters. Once again, we just multiply those rows out, and now we can go to the third shape. The third shape is also a triangle with the same height and base. Its x-bar location is in exactly the same place. Its y-bar, however, now is below the x-axis. So y3 is going to be, now remember, it's 1/3 of the way away from the side with the right angle, which means it's this total distance divided by 3, but if we're trying to measure from this axis, it would be 2/3 of that distance. So that's 2/3 of g, and y3 is going to equal a negative 2.667 centimeters. And multiplying those distances out, now shape 4 here is a circle, and the area for a circle is pi r squared. So that's pi. The diameter is f, so we got to divide it by 2. And the area of shape 4 is negative because we cut it out. Now for x bar and y bar for shape 4, they're very easy. Since our 0, 0 is right here, shape 4 is exactly d away from the center. So the x is positive 7. Since it's on the x-axis, it's 0 centimeters away from the y center. Once again, there's no work to show if those are directly dimensioned. Now we can multiply out our AIXI and our AIYI. And now for shape 5. Shape 5 is this quarter circle. And the area of a quarter circle is the area of a circle, which is pi r squared. The radius is g, but then since it's a quarter circle, we divide that area by 4. Shape 5 was cut out, so that's a negative. Now the x-bar and the y-bar for shape 5 are kind of challenging. Both x-bar and y-bar for this shape have to be measured off the side with the right angle, just like for a triangle. But for a quarter circle, the centroid is located at 4r over 3 pi. 4 times the radius, which is g, divided by 3 times pi. And since the y-axis is here, that's a positive x distance away. Now for the y distance, once again, it's 4r over 3 pi, but it's 4r over 3 pi away from that side with the right angle. So that means to find that distance, we have to take 4 centimeters and then subtract off 4r over 3 pi. So that's g minus 4g divided by 3 pi. And since that's below the x-axis, that is going to give us a negative distance, 2.302 centimeters. Now we multiply those numbers out. And then for our total rows at the bottom, we just add up the columns. We only need to add up 3 columns, the area column, the AIXI, and the AIYI column. The total area is going to be positive 78.65. The total AIXI is going to be a positive 510.5. And the total AIYI is going to be a positive 28.93. And for the last step, here's where we use our centroid formula that I showed you earlier, where the total x bar equals the sum from I equals 1 to n of AI xi divided by capital A. And that might look kind of complicated. It's really not. This capital A is just the total area of the entire shape with all the positive and negative areas added up. This AI xi of I equals 1 to n would be A1 x1 plus A2 x2 plus A3 x3 plus A4 x4 plus A5 x5, which is all of those values added up. So we actually already have both of those numbers. When you do the table like this, it makes this equation very easy. So it's a 510.5 cubic centimeters divided by 78.65 square centimeters. Don't forget to include the signs on both of those values. So the answer is a positive 6.491 centimeters. We do the same thing for y bar. We have those values, the 78 and the 28. And the y bar is a positive 0.3679 centimeters. So the x bar is at a positive 6.491 and the y bar is at a positive 0.3679. Now what exactly does that mean? Well, that's the actual location of the center of the shape. So let's take a look really quick. If we were to say that's the center, I always like to graphically check this. So here's 7 centimeters, so 6.5 is going to be right about here. And then the 0.3 is going to be somewhere in approximately this location. So I like to go back and actually draw it in the diagram. We've removed extra area off of this side, which would push the center back that way. And we've also removed more area from the bottom below the x-axis than we have from the top, so that would push the center up. So that looks to be approximately correct. Obviously that's not going to tell you entirely if the answer is spot on, but it'll at least get you close.